This study presents an immersive virtual reality experience designed to enhance ecological awareness by situating participants in interactive environments affected by climate change. The VR project focuses on three interconnected phenomena: polar ice melting, biodiversity disruption, and coastal sea level rise. Upon entering the simulation, participants find themselves aboard a small boat positioned among large icebergs in a polar seascape. This initial environment serves as a baseline representation of relatively stable Arctic conditions. Participants are given direct navigational control of the virtual boat, allowing them to explore their surroundings freely. The interactive design emphasizes self-paced environment observation, personal impact, and cause-effect learning. The experience features three primary ecological zones that can be visited in any order. Arctic environment. This region presents expansive ice fields, floating iceberg, and native fauna, including animated polar bears. It aims to illustrate the fragility of polar ecosystems and the dependence of Arctic wildlife on stable ice structures. Natural coastal zones. This shoreline setting contains diverse wild animals that inhabit temperate and subtropical coasts. It highlights the vulnerability of coastal ecosystems to rising temperature and the resulting habitat loss and migration pressures. Urban coastal environment. This environment represents populated coastlines with human-built infrastructure. It focuses on socio-economic vulnerabilities to climate-induced sea level rise, including flooding risks and disruption to urban systems. Only after the participant has explored all three areas, the VR system automatically brings them back to the original Arctic starting point. However, upon their return, the scene has undergone a dramatic transformation. The ice has melted, the sea level has risen, and the familiar environment is now partially submerged. Participants are free again to experience the degraded environment conditions, enabling direct comparison between ecological states and reinforcing the consequences of climate inaction. The contrast between the initial and altered states is intentionally stark, providing a visual and experiential representation of advanced climate change impacts. The VR experience is embedded within a larger research methodology that includes pre- and post-experience questionnaires. Their objective is to assess the prior baseline knowledge and attitudes and evaluate the post-experience shift in ecological awareness, perceived urgency, and emotional responses. This integrated VR framework seeks not only to visualize climate change, but to leverage embodied interaction as a catalyst for deeper ecological understanding. By parallelism with the initial and transformed environments and allowing users to witness the consequences of sea level rise, the project contributes to the contemporary efforts to utilize immersive media as a tool for environmental education and climate communication.